Hello, and welcome to the Six Figure Developer Podcast, the podcast where we talk about new and exciting technologies, professional development, clean code, career advancement, and more. I am John Calloway.
I'm Clayton Hunt.
And
With us today is Richard Rodger. Richard was a co-founder and CEO of his previous company, nearForm, where he helped to take the company from scratch to an annual turnover of 17 million pounds. For several years, Richard has been an active member and influencer of the open source software community. Welcome, Richard.
Welcome. Great to speak to you guys today.
so before we kind of get started, would you like to just kind of give us a little history about yourself, tell us about yourself, how you got started in the industry, etc.
Yeah, I'm not a computer scientist by trade. I back to computer science because you kind of have to. But I did philosophy to begin with. So that's really good for getting high-paid jobs. Not. And I had all these summer jobs where I was like working in warehouses with dangerous chemicals and stuff. And a good friend of mine who was doing computer science told me about this awesome summer job he had. This is like 95, where he was like writing Perl scripts to build a website. It was indoor work with no heavy lifting, and it was pretty well paid. I was like, I'm gonna, and yeah, I picked like I did a couple of semesters of a bit of coding, and hey, wow, got up off my rear end, and it was like this speaks to me. I love this stuff. I had done some coding before. I mean, my folks bought me a Spectrum 48K back in the 80s. You guys remember those? And like that was like it was like a simple basic machine, right? So you'd like type in listings from magazines and stuff. But it was in the blood. I should have done it first. And once you get hooked, it's like, okay, you know, I'm a slacker in college to working 60-hour weeks and just reading everything and going back to night school to get the proper qualification. And I love it. I still code. I'm like a coding CEO because I'm never going to stop. And you know, so many advisors and mentors, board directors and all those type of guys are like, you're crazy. It's unprofessional. It's like, I'm not going to stop, guys. I'm just never going to stop. It's too much fun.
Cool.
We're co-CEO of nearForm, and then help take that company to 17 million pounds. You want to tell us a little bit about that particular venture?
Yeah. So that was a wild ride, and it was really good fun. There was 4 of us, so 4 co-founders, and each person brought a little bit of something different to the table. But the reason we all went into business together is we were all coming out of failed startups. So this is like a bunch of guys in their late 30s. They're all married. They have kids, and no money, and really angry wives. We think on crazy startup ideas, and we were like, okay, we got to go into consulting. We have to live. We got to pay the mortgage. And that was around the same time that Node.js was kind of emerging. And we kind of, it looked really interesting. You know, coming from previously, I'd been, you know, enterprise Java, that type of stuff. The previous kind of company before that was relatively successful was in the telecoms industry. But it's really boring. And I really got into functional programming and looking at Haskell and Lisp and stuff like this. But I'm not good enough for Haskell. It's too hard. And I still have to read a monad blog that explains to me what is a monad. I don't get it. So like JavaScript was kind of like, okay, I'm just gonna ease into this functional programming thing. I'm gonna do JavaScript for functional programming, and then I'm gonna move on. I'm gonna get serious. Except we never moved on because Node market was like, and we could sell because, hey, we're Node experts. And we're going to do a meetup. And then we did a conference, which was kind of crazy. Conference is a good story. So we had this really bad website. We had no network, but we sold through the conference that we did every year on Node. So the first year we did that, 2012, we hired the Guinness factory in Dublin. And that was like the venue. So that was kind of an easy sell. And we got 200 people from all over Europe and the US to come, and got a bunch of sales leads. And that kind of really kickstarted the company. We didn't have any money to pay for a conference. And I don't know if you guys have ever run a conference or tried to fund it or something. It's like a crazy thing to do. It's a really, really, really easy way to lose money really fast. So nobody would give us money to run a conference, but we had a little bit of standing with the bank because they kind of knew us from previous companies. So, Ireland is like an agricultural country and going back a long time. And there's a lot of supports for farmers. And one thing that banks do is they give you tractor loans. So tractor loan is for the farmer tractor, right? Except that like he can't pay in monthly installments because he has to wait till the corn comes in or the wheat or whatever. So you pay in like lump sums. So we had a friendly bank manager and she gave us a tractor loan. She put through the paperwork as a loan for, it was the same mechanism.
Right.
Except we bought a load of beer and pizza. I flew people over from all over the world. It was totally crazy. And I mean, it was one of those things where like, let's just do it. And it worked. And name for being experts, even though we were like maybe 6 months ahead of other people. But at Node at the time, I don't know if you remember, it was like there was new versions all the time. Stuff was breaking. It was insecure. It was just crazy that all these modules were exploding. And I still can't explain why did Node take off. That I don't understand. But if you can be in the right place at the right time commercially with a startup, then it kind of pulls you along. I mean, I don't know if you guys listen to podcasts and entrepreneur podcasts, and like one of the big questions is, how do you know you've got product market fit? How do you know the product you're building fits the market? It's like being in love. If you have to ask, you don't have it. So that was, I mean, all the other businesses I've been in, has been in like an uphill struggle. But that business, it was just race to keep up. It was just try and keep your head above water, try and grow the company and move to the next level of client, deliver software that doesn't fall over. And this is JavaScript and so this gets us to Microservice. Why Microservice? The only way to build large systems in JavaScript. The language is so weak.
Yeah, and you're the author of the Tao of Microservices. You want to tell us a little bit about that?
Yeah, so that's my second book. I wrote a book about 6 years ago on building mobile apps in HTML5. I was really convinced, forget about native apps. It's all going to be HTML. It was so wrong. It was just really badly, horribly wrong. There's a startup that failed behind that story. Life made me write another book, and I didn't. I was just like, I'm too burnt out from this. But the problem is, books are really good at helping you sell. So, I mean, the other thing we did with nearForm, the other reason we were able to sell is I would use the book. This is the previous book as a business card. Even if it was like just kind of totally unrelated to the client, I would like, oh, here's my book, and I'm going to sign it and give it to you. So we were like, well, we have to do one on Node, but we were so busy that I never did one on Node. And then microservices movement kind of started emerging, and we had a few speakers, kind of leaders, come to our conference and meet up, and I was pretty inspired by them. So I was like, okay. this is how we solve the scaling problem with this crazy language and architecture that we have. We're building stuff really fast, but it is kind of fragile. And the only way we're surviving at the moment is hiring the best developers we can afford. But what we're selling to our clients is the ability to move their own teams forward. And in big enterprise clients, a lot of the developers are sort of average, right? So how do you teach those teams to build some dynamic? It's the same answer you have in any software architecture. You break it into small parts, and then you figure out how they talk to each other.
Yeah, I was going to ask for those that are listening that just have a basic understanding of microservices, or at least are aware of the term. Why don't you define that for us and make sure everyone has the base knowledge?
Let's start a war. So I did this crazy thing about 3 years ago where I spent a year going to conferences saying if it's longer than 100 lines of code, it's not a microservice. But that's actually too small. So our easily deployable pieces of functionality in your system that communicate asynchronously, usually using messages. The independently deployable thing is really important because you have to be able to mix and match pieces of your system separately. That leads to tons of complexity, and that criticism is totally justified, which is why you need to use things like Kubernetes. And then the communication piece is another important thing because it lets you hide all the data structures and logic from each other, so you get like really, really low coupling. And the high cohesion comes from the physical characteristics of their separate programs. But the practical definition that I use nowadays, having run teams that have built Microsoft systems, is it's something that it has those characteristics, independently deployable and communicates with messages, but it's something that you can rewrite in 1 week, pretty much. Because so there's another aspect to this, right? When should you use Microservice? And they're most useful when your requirements are badly defined and you need to move really fast. You don't have such stress around scaling because you can throw things away if they're the wrong direction. And if you can't throw things away, you're kind of losing some of the advantages. Can we go into like philosophy? Can we talk about philosophical theory? Right.
Sure.
Okay. So when you do computer science, and I can say that now because I'm a proper computer scientist now, you're taught how to go from to the gen. So same code 3 times, write a function. Right? Don't repeat yourself. Find the abstractions, and it's all about. I mean, there's so much miles and miles of ink written about how to find good abstractions and what are good ways of thinking to come up with robust abstractions that are going to survive waves of change to your requirements in your application, and different developers' coding abilities and all this kind of stuff. And you know what? That is totally wrong. It's completely the wrong approach to take in the days when they're badly defined. Particularly from a startup perspective, when you want to get early business value. So instead, invert it and ask, how do you go from the general to the specific? And what I mean by that is, if you can write 20% of the code that solves 80% of the problem, write that first. So some of the examples I like to use are user login, let's say, where let's say it's an enterprise system. Let's just go boring, okay? Because most people have to write these types of systems. You have user login code, you log the particular workflow screen or something. In the early days of the system, where the business analysts are still rewriting all those Word documents all the time, but you still need to demo stuff and you still need to show stuff off and get it validated. You just have a generic login functionality, generic login microservice. But down the road, you're going to need to support different views for a manager, different workflows for managers, for contractors, auditors. There's all these different types of users, but your main user base, the employees or staff of the company, has a set of common functionality. For architecture, you're tempted to try and design an extensible data model or an extensible interface layer, because these other types of users are coming down the road. You don't know what the needs are, but you got to build something that has slots that you can kind of fit extensions into. But what happens is that you end up with an overly complex data model and architecture in the early days where it slows you down, and it's wrong anyway, because it's like humanly impossible to know what the requirements are going to be. It's just, and if you're pretty good and you have a lot of experience, you can kind of not mess it up. So, and that's because you're trying to generalize too many specific things. Instead, with the microservices, what the microservices let you do is build that 20% of the functionality that deals with 80% of the users. And then it's done. And it's kind of done forever. And then when you get new stuff in that's special cases like managers and contractors, you write another microservice. So you might have like a login message, and maybe there's like a type indicator or there's some way of telling it's an employee versus a manager. The employee service wants go this way to the new microservice, which is another week's worth of code, but it handles the weird special cases. And that's a general philosophy, right? It's actually, think about how you can go from the general to the specific. And that has a bunch of knock-on benefits, because you don't really accrete that much technical debt, because you're not trying to, you guys you probably worked with customers that have SQL Server databases. I love SQL Server, by the way. It's the first real enterprise database I used, and I really miss it because I'm in the Linux world now. But it was an old. But you end up with these schemas that have like 200 tables, and each table is like 80 columns, and the database has been there for 10 years, and nobody can change it now. But that's because you have this one shared schema that's trying to represent all these layers of complexity, one type of data that's trying to represent all the different edge cases. And it's the edge cases that kill you. And I think that's where microservices philosophically really help in the early days. You don't know what the edge cases are, so don't even try to write for them. Don't even try to solve that problem.
Yeah, I've worked on a couple of different projects where they talk into this at some point. So they started with a monolithic application and then tried to isolate functionality and segment off individual microservices. Do you recommend that approach, or what suggestions might you have for teams and projects like that?
Okay, so there's two cases, right? So there's the greenfield, and there's one where you have an existing system, and it's like molasses, and the rate of change is slowed down so much, and you're looking for a solution, and you're reading all this stuff about microservices. How can they help? Best case is a scenario when feature a new piece of functionality, that's a microservice, and then somehow it connects to your old system. But you have a ton of work ahead of you. You've got like 6 to 12 months of refactoring that old system. You're never going to refactor it fully. But you can break out macro services. So macro services are like 10 microservices stuck together. So it's kind of the worst of both worlds, but it's still getting to a place where you have to build a deployment automation, you have to build messaging infrastructure, you have to build monitoring. It gets you to a place where you have all of that automation that you need for microservices. I'd still recommend doing that, because at least it lets you move fast, questionable debt. And it might still fester there for another 5 years, but it's not going to impede other things. And you do things like you might have to maintain an old database, but then you write translation layers and this type of stuff. In my book, it sounds crazy, but in really, really, really large installations where you are really, really stuck, you may actually have to go to the wire and write a translation layer at the wire protocol. I have failed in one case. There is one case where we failed to provide a pathway for migration. This is a hard nut, right? These guys were using a system where the business logic was written in BASIC, and it operated against flat files. I think it was something called a universe system. I think that's what it was called. So it's like late 70s, but it just kept on going. Most of the developers were nearing retirement. But they had young guys coming in that they were training up on this basic system because they just had to. It was a monolithic machine as well. It was one machine, just really beefy. And the invoicing system was in the same, as well as the warehouse processing logic. So if we screwed up invoicing. And I mean, we whiteboarded, we did a whole bunch of stuff for 6 months. We wrote little itty bitty Node APIs around the edges. But that system was just so deeply embedded, it just couldn't work. So that was, that's it. Sometimes it's just impossible. But the other side is the greenfield side. And sometimes, a couple of times in your career as a developer over 40 years, you get this beautiful opportunity to build a greenfield system. And there I've got Microservice day one. So I'm doing a new startup, and that's what we're doing. And the reason is, there is a little bit of investment, maybe a month or two of infrastructure investment at the start, where you got to make sure you have, maybe you're using Google Cloud or Amazon or Azure or something. You're probably going to go with Kubernetes because that just has all the features you need to run lots and lots of things. You're going to have to worry about your messaging architecture and logging, and how you're going to do service discovery. You got to answer all those questions, and you got to think about how you're going to document stuff and how you're going to bring things. But you kind of have to do that work anyway. A lot of software development organizations don't do that, so it doesn't matter if they're doing a monolith or a microservice based architecture or what language they're choosing. They're not laying a proper foundation to go fast anyway. So microservices in the early days, you do have to invest, but you kind of have to do that anyway. And then if you follow this general to specific tactic for dealing with the first 6 to 9 months where requirements are really fuzzy and changing, you end up with a system has high cohesion and low coupling. And then you can start worrying about, there's a whole bunch of latency because there's like 5 hops here. So you know what? These 2 microservices have been stable for like 3 months. Well, okay, we're just going to merge that into one code base and take out a network hop. So you can start doing stuff like that because that, this schema is stable. We've kind of gone through several iterations now. We kind of know what we're doing here. So it's not like you paint yourself into a corner, because you can always merge the things together again. So I'm kind of inverted. It's like start off with almost nano services, and then over time, some parts of the system will congeal together naturally. It's like that story, which is totally false, about Stanford University and the pathways, and they never laid any cement, and then they just waited for people to walk around the grass. And then that's where they laid the paving stones. It's totally false, but it's a lovely story. But it's kind of that general tactic.
Mm-hmm. So if you're creating a microservice, you said kind of starting with nano services and then they might merge at some point, but is there, if you're just getting started, is there a limit to how large a microservice should be, or how many endpoints a microservice should have, or anything like that? Any kind of general guidelines to help somebody get started?
Yeah. You've got to keep it pretty simple at the start. So one thing that I've seen that people do is they kind of write either one microservice per CRUD operation, or they have a microservice that handles all the database logic, stuff like that. That is definitely the wrong approach. You've got to break it down functionally in terms of application. Well, in our current system, so our current system is like an event management platform. So there's a lot of discussions that happen between event organizers and speakers and event organizers and sponsors and attendees, this type of stuff. So there's like discussions happen all over the place in various contexts. So you have a discussion microservice that understands how to handle discussions, and everybody else sends messages to that service saying, hey, post a comment or start a new discussion, that sort of thing. Okay. And then in terms of the endpoints, just endpoint, and you're sending messages, which are essentially just JSON documents. And if you've ever used WSS, alarm bells are going off now like crazy, right? Because I've just like thrown aside the last 15 years of REST. This is another issue around designing these systems, is how do you do message routing? Right? How do you get from one microservice to another? How does microservice A know that it has to send a message to microservice B? And it's a really hard problem, because A, knowing about it is, if you had component A and component B in the same monolith, and there was a method call on B, like A needs a reference to B to make that method call. Okay. What's the difference between a method call with an object reference and a network endpoint with an API path? Like, conceptually, philosophically, they're the same thing. So I think if you give yourself flexibility at the message content level, you allow yourself to use things like intelligent load balancing, that type of stuff, where you, at certain parts of your system, expect the message send it in different locations. It's much more powerful. And that means that an individual microservice, to make that really work, an individual microservice has to have a message abstraction layer. So it's not enough to just be a REST endpoint. It's not enough to talk to other REST endpoints. In fact, a lot of the valid criticisms of microservices are criticize that architecture because it leads to a huge amount of not spaghetti code, but spaghetti communication. If instead you have a message abstraction layer, which is just like your database abstraction layer, message, an atomic operation, I just send it. I don't really know who's going to get the message. Receiving a message is just, I'm just receiving a message, and then I handle it internally, or if I don't recognize it or it's malformed, I just drop it. So a message abstraction layer exposes a single endpoint, and you do intelligent or custom message handling within that abstraction layer, and then all of your services use that abstraction layer. And that's because we've found that REST and multiple endpoints and all that just aren't powerful enough to give you the flexibility that I start, right, where you have this user login service, and the front end service, or the service for the login page, the login form, is emitting these login messages. Where do they go? If they're going to a single endpoint, then you've got to deploy Nginx or something like that to split them apart. But if you have a abstraction layer, you can write configuration that means your 80% service deals with 80% of the messages, but sends on the rest to a secondary service that it's hiding. So to the outside world, it just looks like it's one user login service, but it's actually like 3 or 4. So the thing is, it's kind of deeper down the rabbit hole. Once you start really adopting this approach, some of the things that people fight about, like should messages be synchronous or asynchronous, should you use Kafka or should you use service bus, these types of discussions are not so important, because if you can represent the message layer any way you like to the business logic code that your developers are writing, you're free to swap these things in and out, and the developer can just focus on their business logic. So yeah, the way, say if you're thinking about endpoints, you probably need to go up an abstraction layer, and give yourself the flexibility to add, throttling and caching layers, and all the stuff that's going to keep you safe, dealing with overloads and back pressure and all that sort of stuff.
Yeah, it sounds a lot like sort of a command query response, sort of a pattern, and it's sort of what you're describing there is kind of effectively what dependency injection gives you when you're working in that monolithic application. You write it with interface, then you bring in dependency injection, and kind of gives you that abstraction to keep those things kind of decoupled.
Yeah, I think you're right, and it's funny because when I talk to people about this from different worlds, so if I had this discussion with somebody from the Erlang Elixir world, they'd be like, "Oh, we do that. That's exactly what we do. That's the same. It's kind of the same basic model." And they're like, "Oh, we do pattern matching, and what you're doing is like pattern matching." There are a couple of good solutions and a couple of good architectures to allowing you to have this flexibility, and there's just a whole bunch of different implementations. I think people get lost in the details of sort of having strong positions on things. I think that there is kind of a direct, maybe isomorphism is probably a too strong word, but there's a very strong, more than analogy between dependency injection and structures of monolithic software design and microservice message flow design. And then other patterns like the process controller design, the things like Erlang have.
Do you have any resources to get started with microservices?
Yeah, the best stuff is still the stuff Martin Fowler has written on his blog. So Martin Fowler has like a primer article on microservices. And it is the most balanced, fair assessment of where they fit into the landscape. I mean, I'm biased. I wrote a book about microservices. You're gonna get a particular view from me that is like, use microservices, they're cool, and buy my book. Whereas you have other people who have, I think, potentially vested economic interest in maintaining or keeping large enterprise frameworks popular, or they've spent like 20 years and they just know a framework, an enterprise framework, so well that it's not in their economic interest for something else to come along. So that's kind of polar opposites. Martin Fowler's stuff is definitely fantastic to get a balanced view. But if you want to get a really inspiring view, go to the guy who kind of came up with some of the original ideas. This guy called Fred George. And if you search for like Fred George, you'll get a bunch of his stuff. So he's the guy who's like ultra asynchronous, almost nano services. Literally, you're writing polyglot services, doesn't matter what the language is. You're throwing code away as fast as you can write it. You don't need unit tests. He's just like extreme. A great speaker. You should check out some of his YouTube videos if you can, or if he's speaking at a conference, he's worth seeing. But his thing is kind of like, okay, if I really went all in on this is kind of the place that I'd end up. And it's kind of, and queer CQRS. What does the R stand for? What's the R? I forget.
Response.
Response. Yeah.
Is it?
Yeah. That's like a sub pattern. That's like a sub pattern. And there's another fantastic site called microservices.io, which kind of covers microservice patterns and things like that. So the guy who wrote that site also has a ton of experience. And finally, if you want to sort of get a feel for people who've done it in a really, really serious way, with a net source, you'd spend a lifetime getting to know it. And the cool thing about those guys is, they have different approaches. Like they have point to point, and they have intelligent load balancing, and they have all sorts of other fun stuff. It won't tell you how to build microservices, but it will give you some idea of some flavor of what's possible. If you don't have the resources that Netflix has, you're better off sort of choosing one approach and kind of going for it, and just starting small and finding your feet. Definitely don't start with web.
My own chaos monkey.
yeah. We were so good to write one of those. I haven't been. I haven't quite had the courage.
I mean, I have accidentally, but
yeah, but I mean, why not, right? I mean, we should be writing software that can handle chaos monkeys, and it should be there from day one. I'm not. It's hard. That is hard. And you know, I think one of the cool things I think that people forget these are what's the best software is, you know, if we rewind 10 years, and everybody looks back at 10 years ago, you're kind of looking at it going, wow, we were so bad. Stuff, our ideas were really, they weren't scalable, and we were doing the wrong stuff, and we were running our teams the wrong way. And you go back another 10 years and it's even crazier. And it only gets good if you go back to the 60s and they're inventing Lisp and things like that. Right? So I'm really optimistic. I'm really hopeful. I think all of these arguments and discourse and inventing new ideas and trying out different ways and taking things is also, we have this space of possibility that we're exploring. We're like, it's like the 19th century, and we're making railroads, and, like, you know, 1 in 10 boilers explodes and kills people, but the next one is better. I mean, we don't kill people, but one of Fred George's acolytes, I remember him telling me, they were running this high frequency trading operation on microservices. They left the wrong microservice running for a weekend, and they lost 40K.
Oh, wow.
Because it was just way thing. They came in on Monday morning. It was like, oh, we're 40K down. Undeploy. So, you know, I think it's kind of important to just enjoy this era of computer science, of software engineering, because this is still the early days. You know. And you know, 5 years from now, it's going to be something else, right? I mean, microservices even now is a tiny bit old. It's just, you know, the shininess is just beginning to wear off a little bit. Node is so old. I mean, Node isn't shiny anymore, right? It was cool kids until about 2014. But then, you know, it's everybody's doing it now. You know.
Very good. Well, one of the things that we ask everyone is to basically give some words of wisdom. So we ask people, do you have anything that you might share sort of with someone who's trying to get started in the industry, or just has already started, but they're just setting out, and they're, you know, what would you kind of, what words of wisdom, what motivation, inspiration to them?
Buy the right books. I remember buying some of the O'Reilly books on Oracle. Okay, so these were like 1 inch, 2 inch thick books, and I thought these are going to make me into a real software engineer, and these are going to like bring my earnings way up because I'm just going to know Oracle. That was a total mistake. That was a waste of time. The best books in software engineering are the really small ones, the really short ones. Like, read the original Kernighan and Ritchie, read the original Extreme Program. You know, those types of books, just, you can keep going back to them. They just keep paying dividends. Many, really, if you think about it. And there's, you know, you can find lists. There's probably like 10 or 20 core books that you should read. Try and find those books. They're not that hard. There's a bunch of blog posts where people like list like the best software engineering books ever. There is one big book that I will recommend, 1 2-incher, which is Steve McConnell's Code Complete, which took me from amateur to professional, for sure, right? And that's a slog. That's hard work to read, but read that cover to cover. Because that one is worth it.
Awesome. Do you have resources for, well, you obviously gave a few there for people getting started, but what about people getting started into microservice? I know we kind of covered this a little bit, but you have your book. What other ones?
Yeah, so there's an O'Reilly book called Building Microservices by Sam. Oh, the second name has gone out of my head. But you'll find it on the O'Reilly site, Building Microservices. Okay. That's a really cool one. It's slightly shorter than my book, so it's a slightly easier read. I think that because it's kind of easy to get started building microservices, there's quite a few people who have put up example systems. And I'm giving advice to read, but you know what? The most important advice in some ways is to read other people's code. And go and find some of these examples that people have put up where they're like, okay, this is our basic approach, and we've built a system. And the interesting thing about those example systems is that they are not like a lot of sample code doesn't really cover edge cases, and it's not that interesting. But to build a microservice system, you kind of need to have a lot of stuff to actually put things together. And there's new ones coming up every day, and there's a whole bunch of different microservice frameworks and stuff like that. Yeah. So they usually have example systems. That's a really good place to start and get a feel for: do I want to go down the synchronous HTTP point-to-point route? Do I want to go down the Kafka super asynchronous route? And all the variations in between.
Excellent. And then how about people that might just want to follow you, see what you're doing? Do you have a Twitter, blog, or?
So my Twitter is RJROER. So that's kind of it's kind of varied because there's a bunch of business crazy stuff in there, but I still code, so very occasionally. There's some interesting coding stuff out of that as well. I have a Node framework for microservices, which is an implementation of a message abstraction layer. So that's senecajs.org. So that website and has a bunch of resources and stuff. If you want to know about microservices specifically, that's probably a better place to go.
Perfect.
All right. Thank you, Richard. Appreciate you coming on the show.
Thank you so much, guys. This has been fun. You put up with me for far too long. Too many words of wisdom. Don't believe it all, guys. Thank you so much. Really fun. Really good fun.
That was Richard Rodger. Richard was co-founder and CEO of his previous company, nearForm, where he helped take the company from scratch to an annual turnover of 17 million pounds. For several years, Richard has been an active member and influencer in the open source software community.
If you like this episode, please like, rate, and review on iTunes.
Find blog post at sixfiguredev.com.
And be sure to follow us on Twitter at sixfiguredev.
This has been another episode of the Six Figure Developer Podcast, helping others reach their potential. I am John Calloway.
I'm Clayton Hunt.
And I'm John Ash.